All right, so for the Boyce 240 test, like I previously mentioned, there's a lot of overlap between 220, 230, and then the 240 test. The biggest thing I would say that I've noticed over the years is that there's less like pictures of a label. They just expect you to extract all that from the text. So I did post this in the shared OneDrive folder that is that Professor Priori should have sent out to you when she sent out the information about this session and the session later this evening. And just to kind of give you a link to when you click on that folder, if you click on Boyce and then 240, you'll see this available. This was also in the archive folder, so you can see where I've previously worked through it. I just kind of copied and pasted the same problems, so that way you can so we can work through them together. Um, so the first like 10 questions here should be pretty straightforward as what I've written here. You should already know your conversions. You should know how to convert pounds to kilograms, liters to milliliters, pints to ounces, all those things. Possibly inches to centimeters, centimeters to inches. But as we're going through, or after I go through some of the ones that I know are going to be a little bit more challenging or difficult, if there's something you want to see again or just want to refresher on, just either type it in the comments or unmute when I finish and just say or raise your hand actually, and then I can call on you. And if you were like, hey, can we go through like the fluid, calculation? Can we just review real quick how to convert grams and micrograms, things like that? Just let me know. Um, like I said, either raise your hand or just type it into the chat. I have both open and available, and I can see. So the format of the test is the same, 25 questions. You can miss two, and then you pass, and then you're done with this. If you miss three or more, then you're going to have to remediate and then retake the test. For you guys, you need to make sure you're paying attention to your units. Um, some of these questions, the way they're asked, they may already have units kind of established, but some of the questions you might have to know, like as an example, when you do like this fluid intake question, they don't outright tell you that you're looking for milliliters, but at this point, in your fourth semester, you should know that you're looking for milliliters. We're always looking for to convert things. If we're just converting just standard things into a volume, we want it in the metric system, okay? Because that's the standard for medicine and for science. So that's what you would do here. All right. Um, the I just wanted to, I'm just quickly going through this so you can see that there's no labels. It gives you the information you need to set all these things up, but there's no labels pictured. And then I'll apologize in advance. The key should be correct, but I'm not 100% certain, so I will double check as we go through this, but I do believe the key is correct. Um, okay. So I want to start off with the one that typically gives everyone the most difficulty are these heparin infusion questions, where you're being asked to calculate a bolus dose and then a flow rate. And so it's a one question, but there's two questions being asked. So when we look at this question, we can see it gives us a whole bunch of information. It tells us to start an IV drip at 18 units per kilogram per hour. It says that we're going to give them a loading dose of 30 units per kilogram. And then it tells us what our supply is or what our available is. We have a 25,000 unit per 250 ml IV solution. We know that the patient's weight is 172 pounds, so we're probably going to have to convert that to kilograms. And then this question just says, what is the flow rate you will set the IV pump at? And it tells you the flow rate in milliliters per hour. And then how many units will be administered for the bolus. So, um, if this question asked you how many milliliters to administer for the bolus, you actually could not solve it because there is no bolus dose information. So we would need to know a bolus dose, like 1,000 units per milliliter, whatever the bolus dose is, we would need to know that in order to solve for how many milliliters of a bolus. But the question specifically says how many units for the bolus. And so that's how we know what to do. So I'm going to open this up and I'm just going to get to work. So the like I said, the question says first find the flow rate and then find the bolus. Let's do the easy one first. Let's find the bolus first because there's less math to do with that. So the first thing I have to do is see if my pen's going to work. Give me 1 second. I'm going to pause this real quick. It's going to take me I have to restart my computer before I can get it to respond, so I'll have to do that before the next thing. But so what we're going to do is I said we're going to calculate the bolus first. Okay. So what I need to first do is I need to convert the patient's weight in pounds to kilograms. Okay. So what I'm going to do there is I'm just going to divide that number by 2.2. So I'm going to pull up my calculator, which you'll be able to use. You know that 172 divided by 2.2, and I'm going to get 78.18. Now, the way I've been taught to do these is to just round that number right there from the start. For an adult, this should not be a problem. This could be a problem for a pediatric patient, but for an adult, rounding at this step should not be a problem. I honestly think that only North Campus has an issue with doing the rounding at this step. But if you do the patient's weight in pounds, kilograms, and then move right into the next unit and just do a full like dimensional analysis and then get to your final answer, it should still be the same answer no matter what method you do. Um, but as always, I always say just double check with your instructor how they want you to set that up when they're setting these things up. Sometimes when they actually write out your questions, they'll it'll be like an even number, and so you won't have to worry about rounding at all. So just giving you a heads up on that, just in case that's something that's gotten you in the past. But I'm gonna be honest with you, I don't think that's been an issue for students for a while now. So, all right. So now all I'm gonna do is multiply that kilograms to by 30 units per kilogram. So this helps to get rid of the um, kilograms, and then we'll be in our bolus dose. So I always write it like this, just so as far as organization is concerned, just so I know I can cross these out. And then 78.2 times 30 would give me 2,346 units. So that's what we would administer. Apologize for my mouse writing. Okay. So that's how many units. If it asked you to convert this to kilograms, like I said, you would need to know how many units per milliliter for this. So sometimes that number is 1,000, so 1,000 units per milliliter. And so if it asked you that and it gave you that information, then you would just say 2.3 or yeah, 2.3 milliliters is would be if that was the thing. But since it doesn't tell you that, don't do that. The now for the one that I wish I had my tablet working for me is the um calculating the flow rate. So there's a couple different ways you can do this. I always start with the patient's weight because in my mind, I'm trying to get rid of kilograms first and foremost. But if you set this up a completely different way, it's perfectly fine. There's really no, I mean, there's lots of wrong ways to do this stuff, but there's not just one right way. Okay, so you can do this a couple different ways. So what I'm going to do is I'm going to take the patient's weight, which I already established as 78.2 kilograms. Honestly, if there's any lag, this me doing this slow is probably actually helpful. Okay. Then I'm going to take the patient's weight and I'm going to actually multiply it by this 18 units per kilogram per hour. Because again, I'm trying to get rid of the kilograms. So this is 18 units. All right, unit. kilogram hour. Now, you can solve for this, but I'm not going to solve. I'm just going to continue on with the dimensional analysis. So I'm just going to multiply again. Now, at this point, and again, if you don't like dimensional analysis, I respect you and your decision. The main reason I do this, especially on this format, when I'm trying to show you how to solve these problems, is because it helps you to conceptualize what you are getting rid of as you are navigating through these problems. My strategy when I'm ever solving these types of problems is I'm trying to make sure that before I do any math, I'm in the final unit measurements that I want to be in before I do anything else. Now you have the added challenge of you also need to know what you're looking for. Most of these like this flow rate question and these things like that, you will know that they're looking for milliliters per hour. Sometimes they'll tell you that you're looking for it, but if they're asking you to calculate a flow rate or infusion rate, sometimes even drip rate, they are still asking you for milliliters per hour. The kind of caveat to that is that they give you a drop factor, then you would want to calculate your drops per minute, and we'll look at one of those in a little bit too. All right. So like I said, I'm not going to do any math just yet, but right now with the kilograms eliminated, I'm in units per hour. The question though is saying milliliters per hour, so that's why I have to take my IV, my available, and I have to um, calculate that. Now, the other reason I like to write these things out is like, I don't know about you, but I've had a lot of students over the years. They don't know what goes on top or what goes on bottom, or do I multiply this or divide by this? And this is just a strategy to kind of help you organize your material. So in my mind, I know I'm looking for milliliters. I want milliliters on top and I want hours on the bottom. Hour is already on the bottom, so I don't want to mess with this, but I do want to mess with my available. So there's milliliters, and then now I can put my unit down here. So before I even put any kind of numbers, I put these things here so I know that I'm canceling these things out and I'm left with milliliters per hour. So I at least know that I have my units arranged properly. Then I just match the numbers with the units in milliliters. So this was 500 milliliters. I can write, come on. And this is 25,000 units. So it's be a 5 there. Oh, yeah. Choose it. Yeah, I need to erase that. Okay. There we go. We're an S. Now, now you can go ahead and just do your calculation. I think it'll take you less time than me like running through all that stuff. So I'm just going to multiply across the top 78.2 times 18 times 500. And then I set equal in my calculator. It comes out to 703,800, but I'm not going to write that out. I'm just going to divide by the 25,000. And I'm going to get a final answer of 28.152, but we're going to round that to the nearest tenth because that's what we're told to do with these sorts of things. This is another thing. I have a feeling that if you're doing this in reality, like you're working in a heparin kind of situation, you might even round that up just to 28. You might even round it to 30, depending on what what the setting parameters are on the machine, the infusing machine that you're able to set it to. So you may not be able to actually in real world set it to 28.2, but in, the math bubble, the CCAC math bubble, we're going to round to the nearest tenth until, I guess, until I'm told otherwise, not to tell you to do that because that's what I've always been told to do. Okay. Any questions on the like heparin type questions? Are you feeling okay about those? Okay. So again, if you have a question, please raise your hand or drop it into the chat. Um, so a lot of these questions that I put together for you guys is just the same types of questions. It's just kind of built a little bit differently. So instead of 18 units per kilogram per hour, it's 16 units per kilogram per hour for this one, 60 units per kilogram for IV. Then, the patient's weight, and then what's the infusion pump set to. So it's the same type of question. You're just going to use different numbers. For this one here, it just went from this is where we already know what the flow rate is, 36 milliliters per hour, but we want to convert it to units per hour. So this is one of those questions that I feel like it's more of an ATI question that you'll see, but I'll go ahead and work through this one since it's the next one here that might give you some troubles, but I think you'll be okay. So the question is asking, we want to get to units per hour. We have 36 milliliters per hour. We have 12,500 units over 250 ml. And we want to rearrange that to get to units per hour. So there's a couple different ways you can do this. You can set it up so your units are on top, or you can set it up so your hours are on bottom. I typically do flow rate times my available. That's just my choice, but I'm just gonna stick with that because that also follows the same kind of procedure that I did up there on the previous question. So I'm going to take my 36 milliliters per hour. I'm going to multiply by my available. And what am I trying to do? I'm trying to get to units per hour. So I know I want units here. And I know that I want to get rid of ml. So this is opposite of what we did before. But before we went from units per hour to milliliters per hour. Now we're going from milliliters per hour to units per hour. Following the same procedure, it's just the question is just a little bit different. Okay. So the units is 12,500. And the ml is 250. So again, I'm just going to multiply across the top and then divide by the bottom. So I'm going to take 36 times 12500, which gives me 450,000. And I'm going to divide by 250. And I'm going to get 1,800 units per hour. So again, the trick is with these is that you just have to pay attention to how you're manipulating your units. That'll help you with sorting out what you're multiplying and dividing by if you're ever getting stuck. If you're doing these and you're getting them right, and you've been doing these and you've been getting them right, don't change anything you're doing. You're doing it right. All right. I just want to see if there's a let's do this nitroglycerin because this was something that students have asked me over the years that it's not as difficult as it looks, but it can serve you some challenges. But we're going to do basically the same kind of procedure. It says that you have a nitroglycerin IV drip ordered. The order is 5 mics per minute. So we're just going to highlight that. Oops, the wrong button. And we have available 25 milligrams in 250 ml. And it just wants to know what we're going to set the infusion rate. So again, the difference here is instead of it being units, now it's micrograms. Now the trick is, and this is where a lot of students kind of try and take a shortcut, and then it costs them with, unfortunately, a missed question. Micrograms and milligrams, while they're in the same family of weight measurement, they're not the same unit. In order to do this math, you have to have both in the same unit. The other thing is when they ask you to calculate a flow rate, okay, that typically tells you that we're looking for milliliters per hour. So it doesn't directly say that right out of the gate right here, but if you see flow rate, you should be thinking ml per hour. Okay, so I'm just going to write that underneath here. When you see that flow rate, you should be thinking ml per hour. The only time you'd be thinking drops per minute or GTT per minute is if you see something that says like a tubing or drop factor. They have to give you a little bit more information to kind of help navigate that. So I told you I like to start with the flow rate. Even though this doesn't look like a flow rate, that's exactly what this is. So I'm going to take my 5 micrograms per minute. Now, what I'm going to do next is I don't want micrograms. I want milligrams. I also don't want minute. I want hours. So I'm going to do some converting. You can do this any number of ways you like. I'm just going to start with the minutes just because that's the easiest one. So I'm going to take 60 minutes over 1 hour. Okay. Now you can solve at this point, which I think I'm going to solve at this point, just because sometimes this gets a little overwhelming with the fact that you have to do multiple things. Actually, I'm not because then it makes me have to write extra stuff. So I'm just going to continue the conversion. The next thing I'm going to do is I'm going to convert the micrograms to milligrams. So we know that 1 milligram contains 1,000 micrograms. All right, now I can set that equal. So what I'm going to do is I'm going to multiply across the top 5 times 60, which gives me 300. I'm going to divide by 1,000, and I'm going to get 0.3 milligrams per hour. Now, what this allows me to do by converting this to milligrams per hour, now I can connect it to this milligrams per 250 ml. And so all I'm going to do now is multiply by my available, which was the 25 milligrams and the 250 ml. So that point 0.3 times 250 gives me 75 divided by 25, and we get a unimpressive 3 milliliters per hour. So that's also why when you see 3 milliliters per hour, think about how slow that is. That is super slow, right? It is like if someone told you to watch 3 milliliters diffuse per hour and watch it drop out, you would not want to do that. You'd be like, I need to get out of this job because this is terrible. But that 3 milliliters per hour, that's like less than a teaspoon coming out into the patient's IV over an hour, right? So it's going to be a tiny, 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 tiny fractional drop, which is why sometimes, even though it's in milliliters per hour, they still call it flow rate. Okay, I mean, they'll call it a drip rate, even though it's in milliliters per hour. Drip rate, at least for me, in my mind, I'm thinking, okay, drops per minute. Sometimes they don't give you that option, but for this one, if they gave you that option, then yeah, you would set that up. Okay. All right. Oh, I think you're gonna have a okay, here. Let's just since I mentioned drop rate a couple times, let's work through this question about gentamicin, where it gives us a drop factor. Now it just tells us the drop factor is 5. I don't know how you're gonna see it on your test. I think I put that in there like that just as a um because I know that you're responsible for knowing what these different things are. But when you see drop factor listed there, Drop factor tells whenever you see drop factor, if it doesn't give you units, you're supposed to know that it's drops per milliliter. So that'd be 5 GTT per ml. So you're supposed to know that that's what that means. So for every 5 drops, 1 milliliter of the 1 milliliter of the solution has been dispensed. So the next thing it tells you is a couple things. So it tells you we have 75 milligrams in 150 milliliters. We're infusing over 30 minutes. And then we want to repeat every 6 hours because I'm assuming we run out. So this question has a couple of extra pieces of information that we don't need to know. But before I tell you what the information that you don't need to know, let's start with what you do need. So you need a couple pieces of information. You need to know the flow rate. And you need to know the drop factor. So I'm just going to write the GTT per ml. Those two pieces of information will give us our drop rate, which is drops per minute. So how do I get my flow rate? What is a flow rate? Flow rate, as you've learned over the years, is volume over time. So what volume do I have? I have 150 milliliters. What time do I have? Well, I have two times. I have 30 minutes and I have 6 hours. Which one am I going to use? Well, this is telling you to administer the gentamicin, 75 milligrams and 150 milliliters, dextrose, 5% water over 30 minutes. This is the time I want to use. I'm going to ignore the 6 hours because that's just telling you, it's kind of like telling you 4 times a day, right? It's telling you to repeat that. That's what every 6 hours, every 2 hours, every 12 hours, whatever it happens to be, that's just telling you to repeat the process. Okay. Do I care about the strength of the concentration? I do in regards to patient like safety and making sure I'm giving them the antibiotic that they're supposed to be receiving at the strength that we're supposed to be receiving. But for the dosage calculation, I don't care about that. It could be 2,000 milligrams, it could be 1 milligram. It really doesn't matter because when I'm calculating a flow rate, all I need to know is flow rate times the drop factor when I'm calculating a drop rate. So I have all the information I need. I have 150 milliliters, I have 30 minutes, and I have a drop factor of 5. So I'm going to take my 150 ml over my 30 minutes. Now, if you recall in the previous question with the nitroglycerin, I had went and converted minutes to hours. You don't want to do that for this question because our what we're looking for is already in minutes. So if it's in minutes at the end and you start off as minutes, then leave it alone. If that said 150 mil per 1 hour, then you would want to convert that to minutes, either at the end or at the beginning or whenever you decided to do that. But it's already in minutes, so leave it alone. Then we're just going to multiply that number by 5. That's 5 drops per mil. And again, as a double check, I'm crossing out milliliters. I'm left with what I'm looking for, drops per minute. Okay. And then you could just take your calculator again, 150 times 5 divided by 30. And then we all should get 25 drops per minute. So when you see that, like, again, you might say, wow, that's kind of fast. But every 5 drops is a milliliter, right? So that means they're really just getting um they're getting 5 milliliters, so a teaspoon every minute for 30 minutes. And then when that 150 milliliters runs out, okay, after the 30 minutes, then it'll be done. And then 6 hours later, you would repeat the process. So it's, this is IV antibiotic therapy as opposed to, taking an oral based med or taking, a capsule. I think you know that at this point. I think this is supposed to be 5%. Okay. So this is just another example. We already went through a question like this, where we have 5,500 units per hour. The available is 500 milliliters with 25,000 units of heparin. So again, you're just converting units per hour to milliliters per hour. So this is kind of a rehash of the bigger heparin dosage. This is a question that sometimes gets uh, challenges some students when we have 250 milliliters of vancomycin and it's infusing over 45 minutes and we want to know what the hourly rate is. The thing that gets students hung up is what to do with this 45 minutes. So the secret to that is A, you can either just convert it to minutes to hours, or if you already know off the top of your head, you're like, oh, okay, 45 minutes, that's three-fourths of an hour, that's 0.75 hour. That's one way to do it. If you don't like doing that, then I think the more direct strategy is just to take the 250 ml over the 45 minutes. And since it's asking for the hourly flow rate, we're going to just convert minutes to hours. This is also like one of those like kind of quick practice of things that you already know how to do, even if you don't do it with dimensional analysis. You know how to do this. It's just sometimes you just need a little extra like practice with it and just to kind of see how it works. So 250 times 60 divided by 45. And this is a weird one where you get like 333.3333333. So just following my previous kind of rules, even though I don't think in reality this is a real uh, medication administration, I'm just going to round that to 33.3 ml per hour. I don't think you're going to see something like that. And again, if you're not 100% certain about it, because I'm never 100% certain, but no one's ever missed these. So I don't think that it's a or these are very rarely missed because of the rounding at the end. I think most likely they'll have the problem set up so it'll end on a solid number and you won't have to worry about that. But I think it's a fair question to ask your instructor, hey, do I round this to the nearest tenth or do I leave it as a whole number? Um, that would be good to know. Um, you'll probably, I don't have it listed here because I think I just put together a bunch of like kind of common problems that you might run into. You might run into or you're going to probably have a reconstitution question, or you will have a reconstitution question. Remember, with reconstitution, you're going to um, be working on looking at the label to tell you what the ml per or the milligrams per milliliter is. You have to look in the label. That's the secret for that. There's no other kind of trick to that. You've done those since um, since first semester, so you should be good to go with those. Um, the other thing is, if you recall from last semester, if you did the reviews with me, I went over and I discussed the what's it called? The information about uh, Maddie Kessie had put together a study guide from a couple semesters ago, and that's a really good resource. So I think I went through that in the 220 230 review that I did in the spring. So if you want to review that, that's probably not a bad idea. Um, and then we just have a few minutes left. Do you have any questions? Did that answer any questions, or you feel like you're pretty confident with this stuff?
Would you be able to send this dosage practice like to us over email?
Um, I if you email me, I'll send you the link and then you can just download it from the shared drive. Um, if that and then that it would be the same process if that's okay with you.
Yeah, that's fine.
Okay. Yeah, and it should, like I said, if you got the email from Professor Peoria or if she posted it on Blackboard, I don't know how this was information was administered. You should be able to just click on that link and you'll see this there. And then I would say dive into the archive folder, look at the 220, 230 review for Boyce, and it should cover all your bases.
Okay, thank you.
Yeah, you're welcome. Thanks for asking the question. Yeah, and if you didn't get it or you're not or you lost that email, I'm gonna put my email in the chat. And then you can if you need access to it, just let me know. I'll have it for you. Just email me at my CCAC email and I will get that for you. If you're able and available, I will be doing this review again for Boyce 240 at 4:30, I think is the next, yeah, 4:30 today. And like I've recorded this, I'll record that one. Sometimes they're the same type of review, sometimes they're a little bit different. Or if you're working on practicing some things today, if you have questions between now and next week when you take your test, email me. I'm happy to answer questions. If you need to hop on a Zoom, I'll try and make that happen. If not, a lot of times, if you send me a screenshot of what you're struggling with, I can help you out via email.
Thank you very much for doing these reviews.
Oh, you're welcome. I'm glad they're helpful. Uh, so I'll stick around for the next because I'm gonna wrap it up at 11:50. If you have any questions over the next couple minutes, I'm here. If you're done, then we can be done. That's all I wanted to talk to with you about this morning. Okay, see ya.
Dr. Rad,
Yes.
um, on the one intake question, just because sometimes I like in my head I'm confused on certain things to add. I thought that we would include pudding in this, but based off of the answer key, it's looking like you didn't include it, so I just wasn't sure.
Yeah,
I
so
thought it would be
pudding.
similar to gelatin, but I always get confused with that.
Yeah, so here's the so pudding is more, it's when you're making pudding, it's more powder than it
Mhm.
is water. And so it's more of a solid.
Okay.
And it doesn't melt. So like my kids have snack packs and
Hmm.
they're not refrigerated, right? So like but ice cream, which will melt and become liquid, that's kind of the thing. And then Jello's a weird one. When you make Jello, it's more water than it
Hmm.
is powder. Um, I just know that because I've made these things over the years, and that's like I don't know how to like rationalize telling you all those things. I also feel like 2.5 ounces of Jello is probably not really contributing a whole lot to their fluid intake.
Great.
But since you're being asked to calculate that, um, that's why that's there. But yeah, so pudding would not be considered um, a it would be
Like,
considered a solid. It's the same
okay.
thing as like a sandwich. Yeah. And I
Perfect.
put that there to trick you a little bit just because, like you said, you looked at that and you probably made that calculation and you're like, oh, okay, I guess maybe pudding's not supposed to be in there.
Hmm.
And that's why I wanted you to think about, should that be there?
Okay, perfect. Yeah, because the gelatin, like I knew that used to be the one they tried to trick us on, and I knew you had to include that. So like the pudding, I was like, wait a minute. So I just wanted to double check. I appreciate it.
No, you're welcome. And I know other people will have that question too, because yeah, pudding, custard, the fruit cups,
Hmm.
those are all measured in ounces, but they are not liquid ounces, so you don't calculate them as liquids.
Okay, great. Thank you.
Yeah, you're welcome. Good question.